Let's go through a couple examples of changing a fractional binary numeral to its decimal representation. So let's look at this numeral. So we've got 110.0101 base 2. Okay, so I want to look at each of those places and match up the place with what the place value is. So when we were doing numbers 1 or bigger, we do the same thing. So this is the 1's place, the 2's place, the 4's place. So I have 1, 4. I have 1, 2, and I have 0, 1s. Now, on the right side of the radix point, I get into these fractional place values. So I have 0 halves, because there's a 0 in the halves place. I have 1 quarter, because there's a 1 in the 4th place. I have 0 eighths, because there's a 0 in the 8th place. And I have 1 16th, because there's a 1 over here in this 16th place. Now I just need to simplify this. This is 4 plus 2 plus 0 plus 0 plus a 4th plus 0 plus a 16th. That's 6 and 5/16ths, or 6.3125, or 6 and 3,125 10,000ths. Okay, so to do this conversion, all I need to do is figure out what each of these places is, and then add together the ones with the ones. Right? We've got a 4, a 2, a quarter, and a 16th. 16th, 4 plus 2 plus 1/4 plus 1/16 is 6 and 5/16ths. Okay, let's look at another one. So here I have 0.110101 base 2. So that's 0 1s, right? There's a 0 in the 1's place. And then 1/2, 1/4, 0 eighths, 1/16th, 0 32nds, and 1/64th. Notice even though these aren't on the chart, the values keep increasing as if they were to the left, but 1 over, so 2, 4, 8, 16, 32, 64. So the place values are 1/2, 1/4, 1/8, 1/16th, 1/32nd, 1/64th, 1/128th, 1/256th, and so on. But anyway, the key again, I have 1 times a half, 1 times a quarter, no eighths, 1 times a 16th, no 32nds, and 1 times 64. So I need to add together 0, a half, a quarter, 0, a 16th, 0, and 64, giving these all a common denominator of 64. Let's see, that would be 32, and 16 is 48, and 4 is 52, and 1 is 53. It's 53/64, or 0.828125, or 828,125 millionths. That's how much millions. Yep, perfect.